Radiometric instrumentation of Endress and Hauser is often used where other measurement principles cannot operate due to extreme process conditions. In the oil and gas industry, radiometry offers considerable advantages when monitoring interface layers in separators and electrostatic desalters. The oil and gas industry uses so-called separators to break up the mixture pumped from the oil deposit into raw oil, gas, water, and sand. The process separates the four media in accordance to their density. An oil-water emulsion layer develops during the process. Depending on the thickness and position of the emulsion layer, the raw oil flowing over the weir still contains a portion of water, and the desired oil quality is not achieved. If the emulsion layer occurs at a level which is too low, raw oil may be drained off together with the water. This means a financial loss for the producing company. Separators usually have a diameter of several meters. In order to keep the activity of the gamma source as low as possible, it is inserted into the separator. The gamma source is enclosed by a protective tube and positioned in a closed immersion tube. This excludes any contact of the radiation source with the medium. A compact transmitter, which receives the emitted radiation, is installed at the maximum level of the emulsion layer. A second one is arranged in the middle, and a third one at the minimum level of the emulsion layer. The emitted gamma radiation passes through the emulsion layer and is differently absorbed depending on the density of the medium. The compact transmitter detects and analyzes the remaining gamma radiation. The determined density values show the behavior of the emulsion layer. The thickness and position of the emulsion layer is controlled by the addition of demulsifiers, thus optimizing the process. The raw oil from the separator is often fed to a downstream desalting process in order to continue reducing the content of salt and water. The polar water molecules are aligned between the electrically charged plates of the desalter. This favors the coalescence of water molecules. Water drops are thus formed and moved downwards into the aqueous phase, once they have reached a certain size. To measure the oil-water interface layer in the electrostatic desalter, the gamma source is inserted into the tank. Since a more distinct interface layer is formed between oil and water in the desalter, its position is monitored by two compact transmitters. This ensures that the water level remains below the electrostatic plates in order to avoid a short circuit. The most exact measurement of the oil-water emulsion layer is achieved by a multi-detector solution known as profiling. Several compact transmitters are arranged on the tank wall at a close distance to each other. The measuring range is subdivided into zones. The provided density values are transferred to an analyzing program which calculates the applicable density value for each zone. In this way, the density profile of the emulsion layer can be shown by a chart in real time. The measurement thus offers a direct view of the inside of the tank. This not only helps controlling the process in an improved manner, but also provides a higher degree of plant safety. The density profile is analyzed through the density image algorithm and presented in user-friendly visualization. Radiometric interface measurement in the oil industry for precise process control, reliability, and efficiency. The right solution for any application. Endress and Hauser.